Hey everyone, I'm Dr. Surjit Singh. In this video on Python programming, we'll discuss another data type named list. It is much more than the array data type used in other languages. Let us begin. In this session, we shall define lists, iterables, for loop, and range function, scope of a variable, functions and methods, concatenation of lists and slicing, mutable data types, and two-dimensional arrays. A list is a collection of data items. Python lists work like arrays, which means that we can iterate over the elements of the list one by one. In this program, we have a list of 4 integers which we have saved in a variable named data and printed it. We write lists within square brackets and separate the items of the list by commas. Let us write a program to find the sum of squares of these 4 numbers. Before we start processing the data, we store 0 in a variable that we name as memory. This is like clear memory that we perform on a calculator before any summation. For statement extracts items of data one by one and save them in a variable val each time. Val is known as the loop variable whose value is 4 in the first iteration. We end the for statement with a colon and then write the body of the loop for which we indent the statements by 4 characters right. In our case, the body of the loop has 3 statements. In the first of the 3 statements, we find square of val. We print val and its square just to check them. After that, we add the square of val to memory. It becomes 16. With this, the first iteration of the for loop ends. In the next iteration of the loop, val becomes 6 and we execute the 3 statements of the loop once again. Val square is 36 this time. We print both of them and increase memory by 36. It becomes 52. In the next iteration, val is 3 and its square is 9 and memory becomes 61. In the last iteration, square of 5, that is 25, is added to the memory, which becomes 86. All the 4 iterations of the loop are over and we come out of the loop. We had defined both val and val square inside the loop, so their scope is now over and we must not choose them outside the loop. However, we had defined the variable memory before the for loop, so it is still alive. Its value is the required sum of squares of the 4 numbers of the list. Let us now discuss some list functions. Consider the list of heights of 5 students. Print function on list variable heights will print it on the output screen. Len of a list gives its length, which is the number of items in the list. We save it in the variable num and print its value. Type function tells that the heights variable belongs to the list class. Sum is the function that gives sum of all items of the list. We divide it by num to get the average height of the students and print it. In Python, there are some methods associated with each data type. Let us now learn about some methods available for lists. Consider the list scores. One such method for lists is count, which counts the number of elements of the list which have a given value. Note that we invoke methods by writing a dot between variable of the class and the method. We must write a pair of parentheses after it even if there is no parameter present in the method. Count 6 gives the number of times 6 occurs in scores. We save it in n and print it. Change of list items and their order is allowed as list is a mutable data type. Reverse method is used to reverse the order of the elements of the list. Let us print it again. Sort method rearranges the items of the list in the ascending order. We print this also. Consider list A. Items of a list can be of mixed data types. Python remembers the index of all its items. The indexing starts with 0 and not 1. So index of last item is always length of the list minus 1. Append method adds an item at the end of the list. So index of the new item is 3. Let us print the list again. Length function will now show 4 items and not 3. This time we append another list as the item. This gives a list within a list. Len function of list A will show 5 items in it. Extend method takes an iterable. It appends all items produced in different iterations one by one. We use insert method to add an item in the middle of the list. Insert 244 inserts 44 at index 2. The length of the list is now 9. Now consider the list B. Initially it has 7 items. We use pop method to remove the last item of the list. Let us print it. We pop once more and save the popped value in a variable if we need it later on. Let us print the residue list and the popped value. Residual length of the list is 5. To remove a middle item, we give its index in pop. We remove 17 present at index 2, store it in val, and print the details. Clear method is there to remove all items of the list, after which the length of the list is 0. We can join two lists with a plus sign. We call it concatenation. We concatenate lists A and B, which means items of A are followed by items of B. We save it in X and print it. In A plus B, we extend it further. We print it. Same can also be written like this. Plus equal to extends the list. Star list extracts its items. We can use this also to join the two lists. Sometimes we need a portion of a list which is called a slice of the list. We have a list of heights of 5 students. To get an element of a list, we write its index in square brackets after the list variable. Print heights 2 prints the element of the list at index 2, which is 68. Index can also be an integer expression. However, print heights 5 gives error because there is no element at index 5 of the list. We use negative index to get the element from the end of the list. Print heights minus 2 gives the second last item of the heights, that is 65. Slicing of a list gives its sublist. Heights 1, 3 with a colon in between gives a slice of the list that starts with item at index 1 and ends before that at index 3. So elements at indices 1 and 2 only are present in the sublist. We can verify this by printing it. If index before colon is missing, it is assumed as 0. So X starts from the beginning and ends before index 4. In the same way, Y goes from 2 to the end of the list. DC is a copy of the entire list because neither beginning nor end of the list is given. It forms a new list, so we call it the deep copy of the list. However, SC equal to heights does not produce a new list. It is just another name for the list named heights. We call it a shallow copy of the list. Naturally, creation of a shallow copy is much faster than the deep copy. We can change an individual item of a list by referring to it through its index. This statement replaces the item at index 2 with 99. Print SC shows that the shallow copy changes with this change in heights, but the deep copy is not affected. It remains the copy of the original list. For two-dimensional arrays, we use lists within a list. 3 by 3 magic square is given here. This is a list having 3 items. Each item is also a list that has 3 integers each. Magic square 0 is the list at index 0, which is 816, while magic square 1 is the list at index 1, which is 357, and so on. We can refer to the individual integers of the array by two indices. Magic square 00 is the zeroth element of the list 816, which is 8. Similarly, magic square 01 means the integer at zeroth row first column, that is 1. And magic square 21 means the integer at second row first column, that is 9. To save space, we can write magic square in a single line and print it. We can access the rows of the array in a loop and print them. The loop runs 3 times. Each time we get one row of the magic square. Along with the row, we may also print the sum of its elements. For each row, the sum is 15. Let us now write a program to check the column totals. Range function is an iterable which gives values starting with 0. So range 3 gives 3 values to loop variable c that are 0, 1 and 2. The loop over c runs 3 times, taking these 3 values turn by turn. In its initial iteration, c is 0. In each iteration of c, we make column totals equal to 0. This is like memory clear of the calculator before the summation process. For each value of c, we initiate another loop in which r takes values 0, 1 and 2. When r and c are 0, 0, we refer to the element 8 of the magic square. And when r and c are 1, 0, the element is 3. And when these indices are 2, 0, the element is 4. Within the loop over r, we add these numbers 8, 3, and 4 to column total, which becomes 15, and we print it. In the next iteration over c, its value becomes 1. We clear the column total once again. As c is 1 this time, r values 0, 1 and 2 give numbers 1, 5 and 9, whose sum is again 15, and we print this also. For the last column, when c is 2, the sum of 6, 7 and 2 is also 15. We print this also. End clause in the print statement gives a space without changing the line of the output. Therefore, we now have to print a blank line at the end of the loop. Processing for diagonal sum is simple because row and column indices are equal. We start with the diagonal sum equal to 0 and run the loop over c. When c is 0, we add the element 8 present at position 0, 0 to the total. In the next iteration, when c is 1, we add the element 5 present at 1, 1 also to the total. Finally, we add 2 present at 2, 2 to total and come out of the loop and print the diagonal total. For the other diagonal, we add the elements at 0, 2, 1, 1 and 2, 0, for which the sum is again 15. In a rectangular matrix, number of rows is len mat. For each r, we print r plus 1 and stay in the same row. Number of columns of the mat are len mat 0. For each column, we print the item rc in the same line and then change the line before processing the next row. In this session, we discussed lists, for loop and range, length and sum functions, and the methods count, reverse, sort, append, extend, insert, and pop, concatenation of lists and slicing, two-dimensional arrays, and mutation of the list items. Hope you enjoyed the video. Please feel free to ask for further clarifications on my email address given below. I'm looking forward to your comments. Please stay tuned for more.